Hello, this is video M. Video M is about what everybody wants. Arrays. I want arrays. Don't you want arrays? Definition. An array, A-R-R-A-Y, is a collection of several variables An array is a collection of several variables, all of the same type, grouped together under a single name. An array is a collection of several variables, all of the same type, grouped together under a single name. Within the array, each element is distinguished from the others. I'll underline element. I'll come back and say something about that after I write this down before I forget it. Within the array, each element is distinguished. D-I-S-T-I-N-G-U-I-S-H-E-D. Is distinguished from the others by its index number. Or also known as subscript. And when we're using the term subscript, you'll even hear that shortened. Sub is short for subscript when we're working with arrays. Let me read all this back. This is very important stuff here. An array is a collection of several variables, all of the same type, grouped together under a single name. Check. Within the array, each element, that's each individual variable, each one of the variables inside the array is called an element of that array, is distinguished from the others by its index number. Distinguished, that's fancy, big, smashy, fancy word for, that's how you tell them apart. That's how you know which variable's being talked about in the array. It's got to be referred to by its index number, also known as a subscript. The format. Now, this format is just how do you set up an array. We will go into some detail into how do we use an array, but this is how you set it up. Out front, you'll have the type. And we know types already, don't we? We know int for whole numbers, double for numbers with fractions, string for words, char that we hardly ever use at all. But any of those types and at least one space, and then an identifier that I'm going to call array var for variable, array variable name. Now, I hope it's not confusing, but the array itself has one name, and it's considered to be an array variable. But since it's a collection, there are a lot of individual variables inside the array. And if that's confusing, then I think it's probably going to get cleared up once you wrestle with understanding the array example that we look at in code, and you just get used to how you use arrays and how you access the elements and all that stuff. Just take my word for it for now. Then square brackets, that's not a symbol that means here comes another identifier or a weird name or something, but we got to put square brackets, and inside the square brackets goes what's called the dimension. D-I-M-E-N-S-I-O-N. Dimension is a fancy word for how many elements do you want to have in that array. And after we put that number there, then we close square brackets in the ever important semicolon. Got to have a semicolon out there at the end. Okay, now that's what's going to show up at the top of our program when we're setting up an array to use. It's not that different. Maybe the difference is more confusing than the similarity. But it's not that different from just having a plain old garden variety variable, except we've got a number in square brackets after the variable. It says instead of just one variable with this name, we want this many variables with that name. Okay? Now what I'm looking at here, I have written stuff on it. Actually, I've written this stuff on it. But I'm mixing it up a little bit. Rather than put some piddly little examples down here, I've attached to the email where I sent the link to this video, I've attached to that email example03.cpp, example3.cpp, which has array stuff out the wazoo. And I think the easiest way to get a warm, fuzzy feeling about this is actually just to trace through the code. So now that you have all this, I'm going to erase all that so that I'll have room to trace the big example3 program. There. Fresh, clean, whiteboard to use from scratch. This is a trace of example 03. Example 03 trace. Trace just means, you may recall, that we pretend we're the computer and go through this one line at a time. Since it's a sequence of instructions, we go through one line at a time and try to predict exactly what the computer will do when it runs this program. What that involves is setting up all the variables and keeping up with all the values of all the variables as we are hand executing one line at a time. This is absolutely, positively not a waste of time. If you're learning French, it's not enough that you can speak a little French yourself and write yourself a little French language program. You got to be able to understand what other people are saying to you. So being able to trace through a program is the equivalent of understanding the French that people are speaking to you. You're writing your own code, expressing yourself the way you want to in C++. That's your communication with them. French C++, our thought for the day. Example, okay, now from this point, maybe I should pause here, but from this point I'm going to assume that you have access to your own hard copy, perhaps if you have access to a printer. At the very least, I would say you'll want to open a separate window for your editor and look at the code as you look through the video, because I'm not going to write this code on the board. Heck no. I'm going to write the variables and keep up with what this code does to the variables. So make sure you have a copy of example 03 to refer to. Header block at the top, it says, okay, I'm going to have to lose my glasses on this stuff to read. Demo basic array access, include IO stream, yada, yada, yada. We've seen all that stuff before. The first thing that's special to this program is a symbolic constant called max cats. The convention is all capitals, max underline cats. My convention for tracing it, max cats is 5, is not to put one of those open-ended boxes because we can't cross this out and change it. Max cats is permanently 5 unless we go back and change that line number 11 in my hard copy. Line number 11 so that the 5 is something else. Max colors is 100. These are the two symbolic constants at the top of the program. There. Those are set. Those shall not change. Okay, and then we get inside the main program. Let the variables commence. There's an integer variable called nip, N-I-P. There, I do use a memory box because since that's a variable, that could change. But it's got an initial value of 2. There is another integer variable called picked kitties. P-I-C-K-E-D. Not pickled, but picked kitties. That one is not initialized. So that just so I've got a visual reminder there, I'm going to put a question mark, meaning that's a garbage value until further notice. I'm going to skip over the next variable, and then there's another variable, an integer variable called kitty total. I know my K's, my uppercase and lowercase k's look the same. I'm going to try to remember to distinguish very carefully. There, that's a lowercase k for kitty total. That's also garbage. Now, the reason I skipped cat for now is cat is actually what we're here for. Cat is an array. So cat is going to be an array of integers because it's on a line where we're defining integer variables, and it's going to have max cats, or 5 different integer variables inside it. So I'm going to put the array name right here, cat, just like I'm starting up another new variable, except this one has 5 slots. There. And they're actually all about the same size. Okay, now, that's the name of this entire thing, cat. Within it, the index numbers in C++ always start at 0. Cat square bracket 0 is this one. 1, 2, 3, 4. Mental note that you'll want to write down. I'm not writing down notes anymore, but listen carefully. The last index number is always going to be 1 less than the dimension. Let me give you some more examples. I don't want 5 cats. I want 15. Fine. The last index number in that array would be 14. 1 less than max cats. In this case, max cats is 5. The maximum index number is 4. Why? Why? Because we started counting at 0. The first cat in the array is cat 0. That is built into the language. We don't have any choice about that. What else we got? There's another array string called color, C-O-L-O-R. This is also an array, but it's an array of strings, so I can put words in here. Oh, look, that's a much bigger array. In fact, it's got as its dimension on line 19 max colors, which is 100. No, I'm not going to draw 100 variables. I'll get us going, though. There's one of them, 2, 3, 4, 5, 6, yada, 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 last one. And I can put index numbers on the ones that I drew. This is color 0. It always has to start with index 0. Color 1, color 2, color 3, color 4, color 5, yada, yada, yada. What's the last one going to be? Well, max colors is the dimension of this array, and it has value 100. So the last element in this array has index number 99. Okay? And there's another variable, int color count. It doesn't really make any difference where I put them on the board. Since that's color count on line 20, since that's an individual variable, I'll put it up here with the other individual variables. Color count. And it's not initialized to anything, so it's initially garbage. All of this is just setup. All of this is getting all the variables and symbolic constants in place. So now I can start executing the executable statements and see what they do. And away we go. Line 25. The right-hand side has value 7. The left-hand side says put that in cat variable number 0. Here it is, cat variable number 0. You know what? I'm going to switch colors for this. Now that we are actually doing something. There. A purple 7. So far, so good. Line 26. There's a right-hand side of 28. That's easy to evaluate. The left-hand side is ever so slightly more complicated. There's not a number inside the square brackets for the index on the left-hand side. It's nip. So it's got to do a variable lookup. It's got to find out what the value variable nip is, and there it is. It's 2. So what line 26 is actually saying, because of the value of nip, is put 28 in cat square bracket 2. We in the biz might read that as cat sub 2, short for subscript. Cat sub 2 is right here. There goes the 28. So far, so good. Ramp it up even more. 27. Line 27 says on the right-hand side there's a 3. On the left-hand side, where's that going to go? Well, it's going to go somewhere in the cat array, but it actually has to do a calculation to figure out what the index number is. It looks up in memory to find the current value of nip, which is 2. Adds 2 to that, grand total of 4 inside the square brackets on the left-hand side of line 27. So it puts the 3 as slot number 4 in cat. Now, line 28 originally was not a comment, but I had to comment it out or the program would not compile and run. Why, oh why, oh why? All I did was subtract 2. Here's the problem. On line 28, the right-hand side has no problem. That's a 10. Put the 10 somewhere. Where to put it? The left-hand side of every assignment statement, no matter what, the left-hand side of every assignment statement has to be a single individual variable. The problem with line 28 is the left-hand side of that assignment is not a variable, it's an expression. You can't tell the computer to put 10 at cat sub nip and then subtract 2 from where the cat sub nip is. It's got to be a single individual variable and nothing else. Now, I could have put plus 2, minus 2, whatever on the right-hand side. I could tell it to evaluate an expression, but I've got to end up with a single value for that expression, and then it does the left-hand side. The left-hand side is invalid. There is no place in memory with address or with a variable name cat sub square bracket nip, close square bracket minus 2. I beat that to death. Well, I beat it into submission, I hope. Questions about this, you're going to have to note this on your hard copy or on your separate notes, however you're doing it, and bring those up on Tuesday. We'll need to be prepared to discuss this on Tuesday. Let's look at line 29. Line 29 has cat on both sides of the equal sign. Look at that. We always start with an assignment statement on the right-hand side. The right-hand side says cat square bracket nip. Cat square bracket nip, nip is 2, cat square bracket, cat square bracket nip has value 28. So it had to do an array element value lookup to be able to evaluate the expression on the right-hand side of 29. Cat square bracket nip is 28. 28 minus 11, I bet I can do that math. Subtract 11, I'll get 1 and a 7. So there's a 17 on the right-hand side of 29. You can't tell, I know, but I was even covering up the destination of that assignment statement with my thumb. I don't even care where it's going to go until I do the calculation on the right-hand side. So it's a 17, I believe. Now I look, and it says put it in cat slot number 3. Well, that was easy. 17. Okay. Big mess. 30. Look at all that. You know what? I'm going to write line 30 down here. Cat, because that's got so much to it, I'm going to have to point at it to be able to talk about it. Cat, square bracket, nip, slash 2, close square brackets, equals cat, square brackets, nip, star, 2, close square brackets, I hope I'm copying this right, plus cat, square brackets, then cat again, cat, square brackets, nip times 2. Two close square brackets are called for there, and semicolon. Holy moly, what a convoluted mess. Well, we've got to do what the computer would do with that. The computer's got to have to pick this apart. Let me just double check and make sure I copied it right. Cat sub nip divided by 2 equals cat nip times 2 plus cat nip times 2. Okay? Now, on the right-hand side over here, let's just see what we got. Nip all by itself has value 2. Which means then, nip times 2, that's going to have value 4. See how to play this game? Now we know what's inside the square brackets. It's the integer value 4, and yes, the index into an array always has to be an integer. No double value allowed, no string allowed, no nothing. It's got to be a whole number integer value. It's got to be positive. Or, excuse me, non-negative. It can be 0. But that was a 2. 2 times 2 is 4. Cat square bracket 4. So all of this together has value 3. Where did I get that? I had to look up the value of nip. That was 2. 2 times 2 is 4. Cat square bracket 4. Cat sub 4. Cat with index 4 has value 3. So I've done the first part. Now here comes the mess. The mess, you've got to go inside. It's like you're swimming down to the bottom of a tunnel or something. You've got to go inside all of the parentheses or square brackets or whatever until you get to the middle of it. The middle of this ends up starting about the same. Nip still has value 2. That hasn't changed. 2 times 2, that's still 4. Cat square bracket 4. Look it up. Cat square bracket 4 is a 3. So when the smoke begins to clear, we see that inside this bigger set of square brackets is 3. Currently has value 3 based on the value of nip and the value of cat square bracket 2. So cat sub 3 is where I find the value that I need at 17. So far so good? I'm putting the values of the expression up above, and all of a sudden my color array is in the way. I'm going to squeeze this in there anyway. As the smoke finally clears out on the right-hand side, we end up with nothing but 3 plus 17. And 3 plus 17 has value 20. It's not a waste of time to diagram this sort of assignment statement either. I mean, it really is good practice because that's what the computer's going to have to do. It's going to have to look up all these pieces, one little piece at a time, and end up, in an assignment statement, end up with a single value on the right-hand side. In this case, the single value is 20. That's so special, I'm going to circle it there, 20. Now we and the computer had to figure out where the heck that 20 is supposed to go. Nip is getting a workout in this statement. Nip has value 2. 2 divided by 2, I can even do that division in my head. 2 divided by 2 is 1. So cat square bracket 1 in the array is the destination of where the 20 goes. That was so special, I'll keep it in hot pink instead of purple. Now, I didn't do it. Maybe I'll do it later. But I could have copied over any of those array elements I wanted to. There's nothing magic or special about setting a value for them. They're like any other variable. You can set as many different values through the program as you want. Actually, I think I do change one of them in just a second. 31 is commented out. Now, you'll notice my comment on 28 is syntax error. Syntax error means you've broken the rules of the C++ language. What you are trying to say in your statement does not make any sense to the compiler. The compiler will give you one of those dreaded red lines or however it's indicating errors to you and tell you that it can't do that. A logic error, line 31, a logic error is different. A logic error means you did not break the rules of C++. What you've done is something that doesn't make any sense as the program is running. Logic errors are harder to find because they slip through the compiler. Let's look at this and see if we can figure out why it even is a logic error. 31, the right-hand side, -3. Well, you know what? That's the first negative number I've seen, but a negative number, as long as it's a whole number, that's still an integer. So that should be okay. Where do we want to put the -3? The left-hand side, there's nip again. Nip is 2. 2 plus 3 is 5. So that assignment statement says put -3 at cat square bracket 5. Let's go searching for cat square bracket 5. Does not exist. That's off the end. There is no cat square bracket 5. That's where the error is. It'll either crash your program or it'll do something really weird, and the behavior of the program beyond that point will be unpredictable. Oh, it'll be a mess. Don't let that happen to you. You're actually lucky if it crashes your program, because then you know you've got to go back to the drawing board and figure out what you did wrong. And on a more modern compiler, it gives you either something called an access violation. Sounds bad, doesn't it? Access violation means you try to access memory that did not officially belong to your program. Anything beyond element 4 does not belong to our program. A more cryptic error that you might get on your Mac is segmentation fault. Yikes, that sounds like an earthquake or something. Segmentation fault just means, again, that you stepped beyond the memory that your program was officially allowed to access. But either one of those just means you try to access memory that you did not ask for when you set up your variables at the top of the program. Okay, now, assuming all that makes sense, I hope it does, pink to purple down here, all that's got to go because I want to write the next line on the board too. Cat 2, cat sub 2, square brackets 2, and then not plus but star. Star equals, all stuck together, there's no space between those, cat square bracket 4. What fresh new heck is this? Well, C++ is for nerds and geeks, and it has all kinds of shorthand built in. This is shorthand for this longer statement. Cat square bracket 2 equals itself, cat square bracket 2, times cat square bracket 4. Those two are exactly equivalent to each other. What do I mean by exactly equivalent? When your program is compiled, turned into machine language, each of these two statements would turn into exactly the same machine code. The same zeros and ones. They mean to do exactly the same thing. This is shorthand for take the current value of cat square bracket 2, multiply times cat square bracket 4, and then assign that to be the new value of cat square bracket 2. I call them fancy assignment statements. I don't even know if they have an official name. But to me, they're fancy assignment statements. There's not only a star equals, there's also a plus equals. There's a minus equals. There is a divide equals. Just about any arithmetic operator you can dream up. You can squash it down to a shorthand assignment like that. Do you have to use that? You know what? If you want to use that in your program, and there's an occasion to do that, knock yourself out. You can do that. But here comes that French analogy again. You are going to run into this. Maybe not today, maybe not tomorrow, but soon, and repeatedly for the rest of your life. You are, if you keep executing code and trying to figure it out in C++, you are going to run into that. So that's part of being able to read code that other people have written, understanding the shortcuts they may have used. So now that we've written it this other way, actually you can think, even if you run into it this way, you can think about it this way. What we've got to do first on the right-hand side of this traditional assignment is multiply cat2 times cat4. Cat2, whoa, I don't even know if I can do that. Cat2 is 28, cat4 is 3. One moment, please. 28, 3. 3 divided 24, 2, 6, 7, 8, 84. I think so. I don't want to have to do this video again. I hope it's 84. That's going to be the new value of cat2, and there's an example of where I'm copying over an old value in the array, just like I could with any other variable, with a new value, 84. And that's the end of the assignment statements that involve arrays. I'm going to sneak a peek. 720. Okay. Moving right along, line 34, the comment says what's going to happen next. Display all the kitty results. And it prints out a new line. It says max cats, which is 5. So it should print out, if we look at the output down at the bottom of this source code, I've got a commented out session. It should say 5 elements of array cat. Another shortcut you're going to run into is legacy stuff from C. It's not really recommended anymore, but that /n, just like /t was tab over, /n means go to the next line. There are reasons why inline is much better. I won't go into those right now, so I won't link them in the video. But if you do run into /n, that's what it means. It means go to the next line. So this will say 5 elements of array cat, skip a couple of lines, and a for loop. There's nothing magic about for loops. We've seen those before. What's different is, look at that bizarro C outline on line 37. It tabs over line 37 inside the for loop, prints out the value of I. I is the loop control variable for the for loop. So I is going to, one at a time, have the values 0, 1, 2, 3, 4. It's going to kick out when I is equal to 5 before it tries to use it. So what it's going to do is, when it gets to that CL statement the first time, it'll skip over and print out cat, an open square bracket, the value of I, which the first time through will be 0. Then it closes the square bracket in the output and puts a colon and a space, and then it prints out the value of cat sub I. So all in one package deal, that C out line, that output line, is printing out the index number, is printing out the array name with the index number of what you're about to see, and then it prints out the value of that element. And I'm going to have to go to the next page because it's not all on one page. And, well, actually, my output starts at the bottom of that page. On line 81, it says 5 elements of array cat, just like I predicted. Then you can see the output of the for loop on mine lines 83 through 87 are cat 0, cat 1, cat 2, cat 3, cat 4. And it is the values that we filled in the array with the earlier assignment statements. Okay? Why did we get to use a for loop? We got to use a for loop because we knew in advance there were exactly 5 elements of cat that we wanted to see. We don't have to have a while loop and test to make sure it's not negative or anything weird like that. Okay? Now, purple stuff's in the way again. Actually, I wish now that I had waited and done the color array, because the color array is on hold until we get to the bottom of the program. What next? How many cat elements do you want to see again? And we read in the value of picked kitties. Let's see what Fearless User did here. They typed in 3. So when the user typed in 3, the value of picked kitties is no longer garbage. It will now be 3. If picked kitties is greater than max cats, if picked kitties is more than 5, then it's going to print out an error message and not do anything. If picked kitties is less than or equal to 5, then we can print out that many array elements, and it goes to the else part. The else part is much more interesting than the if part here. If part is actually, in a way, a very weak version of input validation. But let's keep going, because what have we got? Picked kitties is 3. That is not greater than 5, so it is going to do the else. It sets kitty total. Variable name is an indicator of what's going on here. It sets variable total to 0. That's going to be a running total. Let's review. Running total, set it to 0 once before you do anything. Normally you go through a loop, 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 loop. It's total, so every time you go through the loop, you're going to add something to that total. Let's see if that's what happens. It tabs over your 3 cat elements. Now I'm going to refer back and forth just to make sure I'm on track. How many cat elements do you want? 3. Your 3 cat elements, and it stays on the same line. There's not an end line at the end of line 48. And then here comes the for loop. It doesn't set up integer variable I until it needs it. In the for loop on line 49, it sets I equal to 0, and away we go. After it sets I to 0, one and only one time for that for loop, it looks to see if I is in fact less than picked kitties. Yes, it is. I is less than 3. So it is going to do the body or the statement block following the for loop at least one time. It prints out cat square bracket I. You know what? This thing, I'm sick and tired of it. Here it goes. Now I can show what the actual output is. Let me catch up. The actual output, it tabs over and prints out your, this is not all complete output, it's just the part we're concentrating on right now. Your prints out the value picked kitties, 3 cat elements, a colon, and a space, and it stays on the same line because there's no end L at the end there. I'm almost caught up. I is 0, it does that at the beginning of line 49. Makes a new variable I just for use in the for loop and sets it to 0. Checks to make sure I is less than picked kitties. It is. 0 is less than 3. So away we go. It prints out cat square bracket I. That's what I wanted to catch up to. Cat square bracket I. Here's the array cat. Square bracket I is going to be square bracket 0 the first time through. So it prints out 7. But wait, there's more. Look at line 51. The right-hand side says take the current value of kitty total, add cat sub I. Current value of kitty total is 0. Add cat square bracket I is adding cat 0, that's 7. I can do that math. 0 plus 7 is 7 on the right-hand side, and it puts it back into kitty total. So there goes the 7. Now we're at the bottom of the for loop. So it goes back up and tests a condition again. Wrong! You really got to get used to this for loop business here. What it does at the bottom of the for loop is the increment statement, that dangling little plus plus I at the end of line 49. So before it goes back up, it does I plus plus, which bumps it up from a 0 to a 1. Now that it slipped in that almost invisible increment statement at the bottom of the for loop, now it goes back up and checks to see if I is less than picked kitties. Is I less than picked kitty? Yes, 1 is less than 3. So it does the for loop again. It prints out cat square bracket 1 this time. Prints out the 20. And a space after it. Then it hits that 51, line 51 assignment statement again. The right-hand side says take the kitty total, which is 7. Add to that cat square bracket I. Add to that cat, not 8, not 7 plus 1. No. This is the index number. Add to the 7, add cat square bracket I. I should be calling that cat sub I. Cat sub I is cat sub 1, in this case, so it's 20. I can even do that math. 7 plus 20 is 27. I didn't leave room for kitty total, but I'll just squeeze it in there. Bottom of the loop, it does the plus plus I at the bottom of the loop before it goes back up. So it adds 1 to I, makes that the new value of I, and that becomes a 2. Now it goes back up and checks that condition again, just as if we were in a while loop. I less than picked kitties. 2 is less than 3. Yes, still true. It's going to do the for loop again. Prints out cat square bracket I. Cat square bracket 2 is 84. Uh-oh, looking at some serious math coming up here. Then it hits the kitty total line again. Kitty total equals, and then on the right-hand side, kitty total plus cat sub I. kitty total is 27 plus cat sub 2 is 84. One moment, please. 27 plus 84. 7, 8, 9, 10, 11, 1, 8, 9, 10, 11. Looks like 1, 1, 1 looks like a binary number, but that's a decimal. 111, 1, 1, 1, base 10. Bottom of the loop. It plus is I again. I'm going to elevate that to be in a verb. Plus is I. Now I is 3, and it goes back around again. It checks to see if I is less than pick kitties. I is 3. I is not less than picked kitties. It's greater than or equal to. That's the opposite of less than. So what's it going to do? It falls out of the for loop. Falling out of the for loop, it hits the cout statement. We're still inside the else because we're still processing the list of kitties that the user wants to see. But now when it hits line 53, it goes beginning of the next line. I'm going to indicate that with a middle arrow just so that I can remember that I need to go to the next line. It tabs over just like we tabbed that over and says total of picked kitties is. That was just printed out verbatim as a string, and then it prints out the value of variable kitty total. Value of variable kitty total is 111, like so. Something like that. Let's take a peek again. How many cat elements you want to see? 3 in this case for this run of the program. Your 3 cat elements are 7, 20, and 84. Yes, yes, yes. And the total of the picked kitties, I'm looking at line 92, is 111. Ladies and gentlemen, our trace so far is on track. Now, all of that was part 1, the kitty cats. And since they dominated the board, not leaving any room for color, now that they're done, I think they're done, yes. Now I'm going to get rid of all this array stuff about cats, so we can concentrate on colors. Now, it's actually not going away. We just don't need it anymore. All variable values are still there. I probably should not have erased it. I'll put my 111 back there. That value is still there. I'm just not going to print it out anymore. And the cat array is still there. That doesn't disappear just because I don't use it. It disappeared because I need more board space to continue with the program. Now, let me redraw the color array of strings. Color. I don't even remember how many elements I put. 1, 2, 3, 4, 5, cha-cha-cha, and 0, 1, 2, 3, 4, yada, 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 99. There. So color gets its turn now, the color array. Part 2 color starts on line 58. 60. Read a list of known length. It's not known yet, but we're about to ask the user. When the user types in the number in advance, then it becomes known, which means we get to use a for loop. And you'll notice there are for loops all over the place. For loops and arrays love each other. They're almost indivisible. When you see an array, you almost always see a for loop. Okay. A romance. How many colors? I'll put that out as the output. When it gets to line 61, it prints a couple of blank lines, and then it says, how many colors? And I want it to match the output, and I don't have the short-term memory of a fruit fly, so I'm going to have to see what it is. 4. 4 says filler as user. I'll circle that because that's what the user typed in. That's not hard-coded into the program. They typed 4. And where did it go? Well, we went to line 62 after they typed in 4 and press enter, and it reads it into color count. So this is not garbage anymore, it's 4. Then it just goes through a for loop. Now let's just look and see what this for loop does. I don't know that we have to go through this in excruciating detail, even though it would probably be good practice for you. It goes through a for loop again for I equals 0, I is less than color count plus I. It's almost automatic. You loop as long as the index variable is less than the number of times you want to go through the loop. And the reason you want to go as long as it's strictly less than is because it starts counting at 0. Just the way array elements start with index 0. See how that matches up with a for loop that way? Okay, so it's going to start at 0 and go 1, 2, 3, and then stop there. And one at a time, on line 65, it reads into color square bracket I. And the user, in response on line 96, typed in red. Then the for loop went around again, green. For loop went around again. Each time, notice, automatically, line 65 automatically moves to the next element at array color because the value of I goes up by 1. So when I is 0, we read into slot 0. When it's 1, we read into slot 1. Now it's up to 2. And the user types in blue. Then the user types in purple. And then the for loop stops because our user typed in 4. And when I gets up to 4, then that matches color count and it falls out of the for loop. I know I'm taking a lot of shortcuts here. If this is confusing, come by during office hours, bring it up on Tuesday's class. So it's read all that stuff in now. Then, to prove it's there, turn around and do another for loop. You'll notice I get to use variable I over and over and over again. Variable I, since I don't set up variable I until I'm inside the for loop, variable I disappears when the for loop finishes. And if I want to reuse the same variable, I can, because by the time I get to line 70, there is no variable I anymore. So I set up a new variable called I, again, from scratch. That's just kind of a standard name for an index in an array and standard name for an index in a for loop. And it prints out, here are your colors, and rather than draw all that on the board, here are your colors, and it goes through basically the same for loop again, except this time it uses a cout statement to print them out one at a time, rather than reading them in from the keyboard. Prints a couple of lines, and everybody's happy, and they go home. The colors are all printed on the same line because there's no inline until after that for loop. Line 101, here are your colors. Prints them out one at a time. Red, green, blue, purple. You see why I didn't want to write all this on the board. You also probably see why I wanted you to have a copy of it open in a separate window on the screen next to the video, or maybe even a hard copy where you write your own notes on it. I'm kind of testing, well, everything is test, everything's experiment. Let me know whether or not this approach is working for you. Have the attached source code, then look through the source code in the video without writing all the code on the board. Okay? There. We have arrays. And I'll see you online.